What if we turned on Voyager 1's camera? Imagine this, a spacecraft that has been traveling alone for nearly 50 years, beyond the planets, beyond the light of the sun, beyond everything, you know. A probe that is still alive, but blind. What if we turned its camera back on right now? What would it see? Voyager 1 is the farthest human-made object from Earth. Its last photograph was taken in 1990, the pale blue dot. 34 minutes later, its cameras were shut down. Since then, it has been crossing the interstellar void in complete silence, without witnesses, without eyes. But if we were to reactivate its visual system, even for just one more image, we could glimpse the abyss. Because looking outward is also looking inward. Because that camera, designed in the 1970s, captured not only planets, but our perspective as a species. And perhaps turning it on again would not show us new worlds, but would remind us how small and precious our own truly is. Everything begins with an image so small it could go unnoticed, yet so powerful that it changed how humanity sees itself. The pale blue dot. A photograph taken by the Voyager 1 probe in which Earth appears as a tiny pixel, suspended in the vastness of space, nearly 6 billion kilometers away. Within that almost invisible point exist all the oceans, all the mountains, every city that has ever existed, every person who has loved, fought, dreamed, and lived. Everything we are and everything we have ever been fits inside that fragile, surrounded by infinite darkness. What makes it even more striking is that this image was taken decades ago, before many of the people who see it today were even born. And yet, it still carries enormous emotional weight. But there is a detail few people know, one that makes this story even more unsettling. Just 34 minutes after capturing that photograph, Voyager 1's cameras were turned off forever. From that moment on, the spacecraft was left completely blind, condemned to travel through deep space without ever recording another image. While humanity went on with its life, Voyager 1 continued forward in silence. Today, it is the human-made object farthest from Earth, more than 24 billion kilometers away. It has crossed the boundaries of the solar system and is slowly entering interstellar space, a region where the sun no longer dominates and where almost nothing has been explored. And it is impossible not to ask, why turn off something as valuable as its cameras? What would it take to turn them back on? And what would they see if we did? The Voyager probes are true survivors of space. They have broken records that once seemed impossible. Not only have they traveled farther than any other spacecraft, but they have also operated longer than any active space mission, more than 45 years. It is difficult to imagine that computers designed in the 1970s, with less processing power than a modern smartphone, are still functioning after decades of exposure to radiation, extreme cold, and absolute vacuum. Every signal Voyager sends today is almost a whisper, yet it remains proof of extraordinary human engineering. When it was launched, Voyager 1 was equipped with technology that seemed futuristic at the time. Its camera system was a perfect example of this. It carried two Vidicon cameras, primitive compared to modern digital cameras, but revolutionary in their era. These cameras worked similarly to early television cameras, converting light into electrical signals that could be transmitted across space. Each camera had a different purpose. One was equipped with a wide-angle lens, ideal for capturing entire planets as the spacecraft flew past them. The other used a narrow-angle lens, designed to observe small and distant details, such as Jupiter's massive storms, Saturn's rings, or, eventually, the solar system itself slowly fading into a collection of bright dots. Thanks to this second camera, Voyager was able to look back and capture the image of the pale blue, a silent farewell to our home. Although the cameras did not take color photographs directly, Voyager used a very clever system to achieve them. Before light reached the sensor, it passed through a filter wheel that included colors such as violet, blue, green, and orange. The spacecraft took several images of the same object, each one using a different filter. Each image was still black and white, but it showed different brightness levels depending on how that specific color reacted. Once those images reached Earth, scientists combined them and assigned colors, creating surprisingly detailed color images. This process is very similar to how the human eye works. Our eyes do not see color directly. Instead, they combine signals from cells sensitive to different wavelengths to build the final image. Voyager did something similar, but from billions of kilometers away, sending fragments of information that, together, revealed the beauty of other worlds. Inside the Vidicon tube, the real magic happened. When photons of light entered, they struck a special plate that released electrons. The more light there was at a given point, the more electrons were released. Then, an electron beam scanned the surface and generated an electrical current that represented the image. That signal was converted into data and sent to Earth, traveling for hours through the vacuum of space. Each image generated about 5 million bits of information. Today that seems insignificant, but when you are billions of kilometers away, transmitting data is an enormous challenge. In its early years, Voyager could send data at a rate of 115,000 bits per second, allowing an image to be transmitted in less than a minute. Today, that speed has dropped to just about 160 bits per second. At that rate, sending a single image would take more than 8 hours, and the signal would take roughly 21 hours to reach Earth. Because the camera could generate images much faster than they could be transmitted, Voyager stored the data on magnetic tapes. It was a simple but effective solution for its time. Those tapes held images and measurements that were sent when communication with Earth was more stable, using massive antennas spread across the planet. So why weren't the cameras ever turned on again? The answer lies in a crucial decision: the survival of the mission. When Voyager 1 took its last photograph, it was already so far away that the planets appeared as mere points of light. It was also about to cross a historic boundary, leaving the solar system. To identify that moment, scientists needed to prioritize instruments capable of detecting interstellar plasma, not cameras. The spacecraft gets its power from a generator that converts the heat of radioactive material into electricity. Every year, that energy decreases slightly. Today, Voyager produces just over half the power it had at launch. The camera system consumed too much electricity, more than 40 watts, so it was shut down to extend the spacecraft's lifespan. Even the software needed to operate the cameras was deleted, and the systems on Earth capable of processing those images no longer exist. Still, curiosity remains. If by some miracle the cameras still worked and were turned on today, what would they see? Contrary to what many people think, they would not be in complete darkness. Although the spacecraft is extremely far away, sunlight there is still brighter than moonlight seen from Earth. However, there is nothing nearby large enough to photograph. The image would be almost entirely black, with the sun and perhaps a few planets visible only as faint points. Perhaps the most astonishing thing is that, despite having traveled more than 23 billion kilometers, the constellations in the sky would look almost exactly the same. The stars are so far away that the change in perspective is minimal. To notice a real difference, Voyager would need to travel thousands of light years. And it will slowly over millions of years, long after humanity no longer exists, when the spacecraft will be nothing more than a silent message drifting through the galaxy. Voyager 1 will continue moving forward without cameras, without spectators, carrying with it a tiny memory of its origin, a small blue, where a civilization once existed that looked up at the sky and chose to explore.